Okay, Algebra 2 students, today we're going to practice using the variable called u. And what that's going to do, when we have these exponents for x or any other variable that are fractions, it's very hard to factor with those. So we're going to use u to substitute for them, and you'll see what I mean by that as we go along. So what you're going to notice is that the middle term, the second term, once you have them in descending order, the exponent of that variable is going to be this amount. It'll be the first exponent times 2. So you see, if I'm sorry. Okay, I apologize. It'll be the second term's exponent times 2 equals that first term's exponent. Okay, because if I multiply 1/8 times 2, you get 2/8, which equals 1/4. So you'll see why we're going to use that. So if you have this exponent, the first exponent and the second exponent, and you multiply that second term's exponent by 2, and it equals that first term's exponent, you're most likely going to use u. So I already set u to equal x to the 1/8. So this is what I'm going to do. I'm going to change this one to x to the 1/8, but I'm also going to raise it to the second power, because an exponent times an exponent, that's all you do is you multiply them. So remember, we just did 2/8 equals 1/4. So that is essentially the same thing. That's like us multiplying it times 1. So we can do that. This one stays the same, and everything else stays the same. Now we're going to substitute u in for x to the 1/8. So we end up with u squared minus 3u plus 2 equals 0. Now we can factor, okay? So if you remember your general factoring, we're going to end up with u minus 1, u minus 2. Oops. Okay, so then solve for u. So u equals 1 and u equals 2. But we're not solving for u. We're solving for x. So we need to go back to where we set u to equal x with its exponent, which is x to the 1/8. So we're going to substitute that back in. X to the 1/8 equals 1. X to the 1/8 equals 2. Okay, but we need x by itself in order to solve for it completely. So we're going to raise it to 8, because remember, an exponent raised to an exponent, you just multiply them, which would give us the exponent of 1. And what you do to one side, you must do to the other. I'm sorry for my sloppy handwriting. So this one, x equals 1, and x equals, okay, instead of putting my calculator, let's see if I can do this. 2, 4, 8, 16, 32, 64, 128, 256. Okay, so this one, x equals 256. But you're really not done. You need to check that these are actual true solutions. So you're going to go back and plug them into this equation to make sure it actually works. So this equation is set to 0. So I'll try this one first. Let's check 1. So I get 1 to the 1/4 minus 3 times 1 to the 1/8 plus 2 equals 0. 1 raised to the 1/4 is just 1. 1 raised to 1/8 is just 1, so you get minus 3 plus 2 equals 0. So we get negative 2 plus 2 is 0. 0 equals 0. So that one does work. X equals 1 is true. Now let's try 256. Okay. Now, one thing you need to remember with fractional exponents, you need to remember what it can turn into. What can a base with a fractional exponent turn into? I'm really hoping that you're thinking of a radical, because you really need to remember that in order to do a lot of these math problems. So I'm going to change this 256 into a radical. My numerator is going to stay as an exponent, my denominator is going to be the index. If this helps, try and think index has a D in it, denominator has a D in it, if that helps. So minus 3 times the 8th root of 256. Not that bad, we just figured that out. Okay, plus 2 equals 0. All right, so what's the 4th root of 256? I'm assuming it's 4, but let me not assume. Okay, hang on. Figure out how to use my calculator. Okay. The 4th root of 256 equals, yes it is, 4. 4 minus 3 times, we already found out the 8th root of 256 is 2. Plus 2 equals 0. 4 minus 6 plus 2 equals 0. 4 minus 6 is negative 2, plus 2 is 0. 0 equals 0. It does work. So in this instance, there are no extraneous solutions. They both work. But remember, you may come to some problems that do have extraneous solutions. You do need to check. Okay?